This is how the earth will look when it is flattened. We are looking the earth from the south pole. In this chart, we cover from Australia to South America. We almost cover 180 degrees of the earth. This chart cannot be used for navigation because there is no clear details which is used for safe navigation. This chart is called a mnemonic chart. This chart is used for planning a great circle sailing. As you can see here, all the latitudes are parallel to each other. These are the southern latitudes. From 0, it increases towards the pole until 90 degrees at the pole. All the longitudes are converging lines at the poles. As you can see here, the longitudes 150 degrees, 160 and 180 degrees, and then the western longitudes are converging towards the pole. All the longitudes are converging lines and latitudes are parallel to each other. As it was mentioned before, this chart cannot be used for navigation. Now you will see the actual charts, nautical charts that are used for navigation. This is the nautical chart. This chart is called a Mercator chart because the projection is a Mercator projection. In this, all the longitudes are parallel to each other and the latitudes are also parallel to each other. You can see here, this is 30 degrees west, 35 degrees west, and the longitude is parallel. And you can see 25 degrees west, which is also parallel. So all the longitudes are parallel to each other. They are not a converging lines as we saw in the previous chart. Similarly, the latitudes are also parallel, similar to the one that we saw on the mnemonic charts. A circle consists of 360 degrees, and you can see here this is from 0 going up to 180 and going back to 360 degrees. So any line drawn will represent a particular angle. For example, we have here a line which is of 139 degrees, 139 degrees. So how to find out this line is 139 degrees? So I will explain you the procedure. This is a parallel ruler. We have studied the concept of transferring lines using set squares in our school days. This is a similar to this one is similar to that. What to do is the center point of the circle, and then you have to mark 139 degrees. Okay, now you have to connect both these points. Once you have connected both this point, see, now this is at an 139 degrees angle. Just hold one point, one side of the ruler, and move the other one. You see, exactly it comes to 139 degrees. So you can draw a line using a parallel ruler of required angle. As I mentioned before, the mnemonic chart cannot be used for navigation, and this chart can be used for navigation. How do we know that this can be used for navigation and what all information is available here? First of all, The main important thing that you need is the compass rose. Compass rose is a circle on the chart which marks 0 to 360 degrees. Apart from this, we can have land or an yellow color. The boundaries of the land are being marked. Then the currents prevailing in the area. This is a Brazilian current. This is South Equatorial current. Here also you have South Equatorial current. Okay, mainly the depths. You see here, it's 5,215 meters depth. In some other place, 4,000 meters, 5,200 meters, 4,900 meters, and so on. As we get close to the land, the depth decreases. 3,000, 3,800, 2,500, 1,800, 671, 45, and 10 meters. In this chart, on depths below 100 meters are given in blue color to show that the areas are of lesser depth. Less than 100 meters depth is given in blue color. Also, this is an island. Name of the island, and this one 600 in bracket is the height of the island. This is not the depth of the island, whereas this one is the depth of the sea. This one is height of the island. Apart from that, you will get the magnetic variations for the location. These are called magnetic variation lines. Since this chart covers almost 1,200 nautical miles, almost equal to 2,400 kilometers area, you will have lot of magnetic variation lines. One is this. You will have one more here. You have one more here, 23 degrees. You have one more here. There are a lot of magnetic variation lines given in the chart. This chart is called a small scale chart because it covers larger area. Okay, and if you see here, this difference between 18 and 90 degrees, this is distance equal to 60 nautical mile. 1 degree is equal to 60 nautical mile, and this small segment is 5 nautical mile, 5, 10, 15, 20, so on up to 60, and this is half of it is 30 nautical mile. So as you see here, the scale for 1 nautical mile is very small. That is the reason this is called a small scale chart. This chart are useful for ocean navigation, that is from one side of the Atlantic Ocean to the other side of the Atlantic Ocean. This charts can be used. This chart covers almost, this is a known position, there is a second day known position, this is the third day known position, and this is the fourth day known position, and you will have one more position here. So this chart covers up to almost 6 days of navigation. But with this chart, you can't go close to the shore because your depths close to the shore are not clear. So we have to use a little larger scale chart. This is the second little higher large scale chart. This one covers the area east of China. This chart covers almost 540 nautical miles, that is equal to 1200 kilometers. Similarly to the previous chart, we can see these are the submarine underwater pipelines from the rigs. These are the rigs, markings of rigs, and these are the pipelines that are connected to the land. You can see here, this is the underwater cables. This is another underwater cable. There are a lot of underwater cables running in this area. You see here, there are so much of underwater cables coming out from a small island in Japan. Similarly, all these underwater cables runs to different countries. Some to China, some to Korea, some to Japan, and all other countries. Some are trans-Pacific. From here they go to US. There are a lot of underwater cables in this region. Apart from this underwater cables, there is a marking for the most predominant current, Japan current, called Kuroshio current. This is the place and the direction in which the current acts. As I mentioned in the previous chart, the depth decreases as you go towards the shore. You can see it was initially 4,000, going down. Now it has come to 960,000, further decreasing 77, and further decreasing 20 meters, 10 meters, and so on. So with this chart, you can make an approach toward until this position. But hereafter, to further go inside, you need a bigger chart, as shown in this figure. 1759 is the chart required to enter this area. All these depths are divided by contour lines. You can see here, this is 100 meters. The depth on this side of the line is less than 100. On depths this side of the lines are more than 100. Similarly, you will find for this is the 20 meters. Depths here are less than 20, depths here are more than 20, and so on. See, you can find here depths of 6,000 and 4,000. Depths on this side are less than 4,000, here are more than 4,000. Depths on this side are more than 6,000, this side is less than 6,000. In the previous chart that we saw, the one subdivision was equal to 5 nautical miles. But in this chart, you can see one subdivision is equal to 2 nautical miles. So total, this one is 30 nautical miles, and from here to here is another 30. So this one constitutes a 60 nautical miles. Going further, this is the next larger scale chart. This chart is for the region of Indonesia, Bali, the most popular tourist destination. In this chart, you can see this is equal to 5 nautical mile, and this is 1 nautical mile. So this one is another 5 nautical mile. So here you can have a clear scale for 1 nautical mile. which was not available in the previous two charts. So this is the next higher large scale chart. In this chart, you can have a clear description of the coastlines, the reefs. These are all the green color ones are all the reefs, and the boundaries of the island or the land area. Continuing further, we will see the next large scale chart that is available with us. You can see the distance for 1 nautical mile in this chart and the distance for 1 nautical mile on the next chart. It is evident that the scale has increased for 1 nautical mile. This is the chart for Philippines area. As you can see here, it is marked depth in meters, which means all the depths indicated in this chart are in meters. The direction of the sea current is being indicated. Also, this is a tidal rip. Tidal rips are caused when two currents meet each other at a particular pace. If you can see here, this is the chart number for this location. Using this chart, we can approach or berth for any port in this area. This is the large scale chart for this area. Here, the green color that you see is the reef. The name of the reef is Tumindao Reef, and the yellow color ones are the land areas. The lands are in yellow color, the reefs are in green color. The water bodies are in blue color. This one is a lagoon. The depths in this area are very low, maybe less than 1 to 2 meters. Next to this land area, you can see depths going up to 111 meters, 84 meters, 188 meters, and this one is the direction of the current in this area. The current varies during high tide and low tide in this direction. This is a lighthouse. The name of the lighthouse is Dhananjayan. The characteristics of the lighthouse is flashing 10 seconds. The height of the lighthouse is 36 meters and the visibility range is 15 miles. This is also available in the AAS. The characteristics of this lighthouse can be obtained in the AAS with the name Dhananjayan. Apart from this lighthouse, there are also buoys which is found in the chart. This is a buoy. This buoy indicates isolated danger, which means there is a danger below this buoy. This is located on a reef called Gem Reef. The characteristics of the buoy is flashing 2 for every 10 seconds. That means every 10 seconds it will give 2 flashes. Let's go to the next large scale chart that we are going to use. But before that, I just want to give you a comparison between the scale of both the charts. This is 1 nautical mile on the present chart, and this is the 1 nautical mile for the next large scale chart that we are going to use. Now you will have an idea of the change in scale between the two charts. This is the next large scale chart. We just now saw the scale comparison between the two charts, and this chart is for Port Walcott, Australia. These are the designated anchorages for ships which come to the port and have to stay 2 or 3 days before berthing. The ships anchors here and wait for their turn before berthing. As we come from the sea, we have to pass through a buoyed channel. This buoyed channel takes us to the berth. In this buoyed channel, there is a maintained depth which is indicated in the channel, which is around 15.6 meters, and we come to the terminal area or the port. In this area, you can see the depths are lesser than that on the open sea. With this chart, berthing is not possible. So we will see the next large scale chart for the port. These are the beacons that are present on both sides of the channel. The port side, that is the left side, has red colored beacons, and the starboard side, that is the right side, has the green color beacons. And you can see the characteristics flashing red or green every 2 seconds. The entire channel is marked with beacons on either side to show the edges of the channel. There is a maintained depth of 15.6 meters inside the buoyed channel. Outside of this, the depths will vary, either less or more, depending upon the area. You can see a buoy here. The difference between a buoy and the beacon is the buoys are floatable and the beacons like this are stationary or pillar type structures. As we proceed towards the land, the depths are also reducing. You can see here depths of less than 10 meters, whereas out at sea it was more than 20 meters. The depth gradually reduces towards the shore. This is the terminal for Port Walcott, and here you can see berth number 1, 2, 3 and 4, and there is a maintained depth of 19.1, 19.4 meters in this terminal. This is the second terminal with berth number 5, 6, 7, 8. They have a maintained depth of 20.0 meters. Apart from this, you can find a leading light. This leading light here has an angle of 253 degrees, 253 degrees, and this entire basin is maintained with a depth of 15.6 meters, and blue region is a region of lesser depth of less than 10 meters. The leading lights helps the ship to come inside and turn around and berth inside the harbor. As the ship comes in, this will turn around and berth alongside, and once the loading is completed, they will move the ship out and it will proceed into the buoyed channel. Turning a ballasted ship is easier than turning a loaded ship. This depth marking 13 by 8 indicates 13 meters and 80 centimeters. The entire chart is being surveyed, and you can see the depths for the entire chart area. For making such a detailed chart, there has to be an extensive survey carried out by the local government for safe navigation of the ships. While we are seeing charts which has depths in meters, and their indication is like this: blue, green, yellow. But there are some charts which has depths in fathoms. When the whole world goes in one direction, there are a few countries which tend to go in a different direction, and these countries have charts in fathoms. What is fathom? 1 fathom is equal to 1.83 meters, and in this you can see all the land areas are grey in color, the water areas are white, and their depths are marked in fathom. So 93 means 93 fathoms, and it's marked in the chart depth in fathoms. So these are some other charts which you find for navigation, in which the depths are given in fathoms and not in meters. So there is in a large scale chart, the magnetic variations are indicated in the compass rose. both in the charts in meters and the charts in fathoms. Whereas in a small scale chart, these are indicated as lines.